The SpaceX astronaut training program is designed to prepare astronauts for the full spectrum of challenges they may face during space missions, from the technical complexities of operating spacecraft systems to the physiological and psychological adjustments required for living in space. The training involves a wide range of activities, including hands-on experience with spacecraft systems, emergency protocols, physical conditioning for space environments, and preparation for life aboard the spacecraft. This program ensures that astronauts are equipped with the necessary skills and resilience to handle the demands of long-duration space missions, such as those to the International Space Station, ISS, or potentially to destinations farther out, like the Moon or Mars. 1. Spacecraft Systems and Operations. The Crew Dragon spacecraft, developed by SpaceX, is a critical element of the company's astronaut training program. As one of the most advanced spacecraft designed for human spaceflight, Crew Dragon combines autonomous and manual operations, which requires astronauts to become proficient in both automated and manual spacecraft management. Understanding the spacecraft's systems, controls, and capabilities is the first step in ensuring that astronauts can operate the spacecraft safely and effectively during their missions. Automated systems training. Crew Dragon's autonomous capabilities are one of its key advantages, enabling the spacecraft to perform tasks such as launch, orbital insertion, rendezvous, docking with the ISS, and re-entry without direct input from the crew. Astronauts begin their training by learning the basics of how these automated systems work. They study the spacecraft's flight software, navigation systems, and how the spacecraft autonomously adjusts its trajectory and orientation during various mission phases. While Crew Dragon can operate autonomously, astronauts are trained to monitor the spacecraft's systems throughout the mission to ensure that everything functions correctly. Astronauts are also trained on the procedures for activating the spacecraft's automated flight systems, including the pre-programmed sequences used for launch and docking. Crew Dragon is designed to autonomously navigate to its destination, but astronauts must be prepared to take over in case of a malfunction or a failure of the automated systems. To prepare for this, astronauts undergo simulated flight scenarios where they practice responding to the automated system's failures. Manual control and overrides. While Crew Dragon can autonomously handle most of the flight, astronauts must be capable of manually controlling the spacecraft in the event of an emergency. This aspect of training involves practicing the manual navigation of Crew Dragon during various mission phases, such as launch, orbit insertion, and docking. Astronauts learn how to use manual flight controls to adjust the spacecraft's trajectory, speed, and orientation in response to unexpected problems. Astronauts also train for manual docking with the International Space Station, ISS, in case the spacecraft's autonomous docking systems fail or require human intervention. In these simulations, astronauts practice using the spacecraft's navigation system to align with the docking port on the ISS and perform the intricate steps involved in safely attaching the spacecraft. The training emphasizes the importance of timing and precision in manual control, particularly when approaching or separating from other spacecraft or space stations. Even though the spacecraft is designed to dock automatically, astronauts must remain alert and capable of taking manual control if the situation requires it. 2. Emergency training and crisis management. Space travel involves significant risks, and astronauts must be prepared for a wide range of emergencies. The emergency training portion of the astronaut program is designed to prepare astronauts for any situation where the spacecraft's systems fail, or an unexpected crisis arises during the mission. This comprehensive training includes both practical and theoretical exercises that cover the many potential risks of space travel. Fire and cabin depressurization protocols. One of the most critical parts of emergency training is learning how to deal with the loss of cabin pressure. In space, a loss of pressure in the spacecraft could have catastrophic consequences, so astronauts are taught how to respond immediately if this occurs. They are trained to use emergency oxygen systems, quickly don spacesuits, and activate emergency life support systems. Astronauts also practice sealing off damaged sections of the spacecraft to prevent the loss of pressure from spreading to the rest of the cabin. Additionally, fire on board the spacecraft is another highly dangerous scenario that astronauts are trained for. Fires in space are particularly challenging to manage, as there is no gravity to cause flames to rise and disperse. In the absence of gravity, flames can behave unpredictably, potentially spreading in all directions. Astronauts trained to use onboard fire extinguishers and suppression systems to manage fires in microgravity. These emergency scenarios are practiced in a variety of simulated conditions to ensure that astronauts can respond swiftly and effectively when faced with real-life emergencies during a mission. Abort and escape procedures. SpaceX has designed its spacecraft with abort and escape systems that can ensure astronaut safety during critical phases of the mission, such as launch. Astronauts are trained to execute the spacecraft's abort procedures, which are designed to rapidly propel the Crew Dragon away from the rocket in the event of an emergency during launch or ascent. These escape procedures are essential for ensuring the crew's safety if something goes wrong during launch or the early stages of the mission. In training, astronauts practice abort scenarios where they must activate the escape system and ensure that Crew Dragon separates from the rocket in the event of an emergency. They also practice the procedures for returning to Earth after an abort, which includes activating the spacecraft's parachute systems and preparing for a safe landing. Spacecraft also have an automatic abort sequence that can be activated by mission control if an emergency arises. However, astronauts are trained to manually activate the abort system if needed, which is critical for ensuring a rapid escape in the event of a malfunction. 3. Spacecraft docking and rendezvous. Another key component of SpaceX astronaut training is docking with the ISS. This operation involves bringing the spacecraft in close proximity to a space station and precisely aligning it with the docking port. SpaceX astronauts are trained to safely dock with the ISS using both autonomous and manual procedures. Autonomous docking procedures. Crew Dragon's autonomous systems are designed to handle the docking process without crew intervention, using sensors and flight software to align the spacecraft with the ISS. Astronauts are first trained to understand how these automated systems work and how to monitor the spacecraft's progress during the approach to the ISS. Before actual flights, astronauts practice docking in a variety of simulated environments, familiarizing themselves with the processes that the spacecraft's autonomous systems will use. These include the detection of the docking port on the ISS, the fine-tuning of the spacecraft's speed, and the final adjustments to ensure a secure connection. Manual docking practice. Although Crew Dragon is designed to autonomously dock with the ISS, astronauts are also trained to take over manual control if necessary. This manual docking practice involves complex procedures, as astronauts must use backup systems to align the spacecraft with the docking port, adjusting the spacecraft's approach to ensure a smooth docking. Astronauts practice these docking maneuvers in simulators that recreate the ISS and the surrounding space environment. They learn how to adjust the spacecraft's speed and trajectory in real time, taking into account the spacecraft's movement and the ISS's rotation in orbit. Rendezvous with other spacecraft. On some missions, Crew Dragon may rendezvous with other spacecraft in orbit, requiring astronauts to adjust their spacecraft's trajectory to match the orbit of the target spacecraft. Training for these rendezvous procedures involves precise calculations and maneuvering to ensure that the spacecraft meets its target at the correct location in space. Astronauts practice calculating orbital adjustments, performing course corrections, and ensuring that both spacecraft are in a stable orbit before proceeding with rendezvous and docking. 4. Physical conditioning for space travel. One of the most unique and challenging aspects of space travel is the physical toll it takes on the human body. Microgravity, or weightlessness, can cause changes in muscle mass, bone density, and overall health. As part of SpaceX's astronaut training program, astronauts are subjected to rigorous physical conditioning to prepare them for the physical demands